Hi, welcome to this video. In today's video, I'm going to look at a very interesting problem of International Mathematical Olympiad of 2006. Okay, the question: determine all x and y are the integers numbers such that we have this equation 1 plus 2 to the x plus 2 to the x plus 1 equal to y squared. Okay, before we start, you can give hints to this problem and keep watching the full solution. Okay, so I would remind you also about this problem. It's very confused problem because it contains positive and negative solutions. Okay, obviously before you start solving this problem, always try the obvious cases when you have x inferior than 0 and also x equal to 0 and x greater than 0. Okay, let's start this equivalent x inferior or minus 1. Okay, so that's mean 2 to the x inferior to 1 over 2. Okay, equivalent 2 to the x inferior 1 over 4 and 2. Okay, so this one is a y squared. Okay, so we have y squared between 1 and 2. There is no solution. We don't have perfect square here, so that means there is no solution for that when you have x inferior or equal to minus 1. Okay, let's take another solution. Okay, when we have x equal to 0, this implies 1 plus 2 to the 0 plus 2 to the 1 plus 1 equal to y squared, equivalent 1 plus 1 plus 2 equal 4 y squared. That's mean we have two solutions, plus or minus square 2. Okay, now we have the solution for this one. So the solution now is become 0, 2 and 0 minus 2. This is the solution for in the case of x equal to 0. Let's try x equal to 1. 2, 1 plus 2 to the 3 equal y squared. It's 1. 2 to the 8, 10, 11. We have 11 equal to y squared. Since we don't have the perfect square, that means there is no solution as well. Okay, now let's try x equal to 2. So this one equivalent 1 plus 2 to the 2 plus 2 2 to the 4, 5 to the 5 equal to y squared. Okay, so 2 to the 5, so 2 to the 5 is 32. 32 plus 4 is 36, plus 1 is 37, so y squared is 37. Since we don't have the perfect square here, that's mean no solution as well. No solution. Now let's clean up the board and move on to when you have x is greater than 2. Okay, now I'm going to bring number 1 to the other side. Okay, so we'll have 2 to the x plus 2 to the x plus 1 equal to y squared minus 1. This one I can factor this one on this form. Again, let's take the number 2 as a multiplier of these two terms. 2 to the x multiply by 1 plus 2 to the x plus 1. Okay, equal 2 to the x minus 1 multiply by 1 plus 2 to the x plus 1 equal to y 1 equal to y minus 1 multiplied by y plus 1. Okay, this, if you take a look at these two terms, this is odd number because 2 to the x plus 1 is an even, plus 1 it becomes odd, so 2 to the x is an even. Okay, so even multiplied by odd is giving you even. Okay, so that's mean since we have this number is an even, that's mean this is odd also, this is even, this one is even as well. So left hand side is an even, implies right hand side must be even as well. Okay, I'm going to check these two terms, they are even or not. Okay, so the product of this one is an even. That's mean, let's suppose y plus 1 is an even. So that's mean y plus 1 is an even. That's mean y is an odd. So since y is an odd, that's mean y minus 1 is an even. Let's take the inverse. Let's take 1 minus 1 is an even, but y is an odd. But y plus 1 is an even. So that's mean both of these numbers are even numbers. Okay, this one implies also y minus 1 and y plus 1 are both even. Okay, let's take the difference of these numbers. So y plus 1 minus y minus 1, 1 minus 1 equal to 0, 1 minus 1 equal to 2. So now we have the combination linear of two numbers. So the combination linear of two integers is a multiple of their GCD. Okay, greatest common divisor. Okay, so what does mean? That's mean 2 is divide GCD of these numbers, the common factor, the larger divisor of these terms, y plus 1 and y minus 1, 1 plus 1, y minus 1. Okay, so what does mean? Since we have these two numbers are even, that means GCD is 2. Okay, so the GCD of y plus 1 and y minus 1 equal to 2. Okay, so what does mean? That's mean one of these numbers, y plus 1 or y minus 1, is divisible by 2, not 4, because of the GCD. Why is not 4? Because of GCD. Because GCD has to, the maximum number they can take is number 2. So one of these numbers is divided 2, not 4. Okay, in earlier proof we proved one of these numbers, y plus 1 or y minus 1, is divisible by 2 because of GCD. That's mean y plus 1 or y minus 1 is a multiple of to the x minus 1. One is going to take number 2, the other one is going to take 2 to x minus 1. But at this time we don't know which one is taking 2 to the x minus 1. The one is taking 2 to the x minus 1 is not divisible by 4. We see that at the end. Okay, so now y plus 1 is a multiple of 2 to the x minus 1. Okay, so that's mean y plus 1 equal to the m 2 to the x minus 1. Okay, so the m is greater than 1 and m is an odd. I'm going to argue why m is an odd and m is a positive superior than 1. M is an odd because it was an even before. Okay, if you take a look at number 2, is the same thing as written y plus 1 equal to m 2 to the x minus 1. Since we have y plus 1 is an even, and also this term should be even. And if m is odd, y plus 1 is still even, because it has a power of evenness in previous expression. As you see here, if you consider y minus 1 is a odd, it's not going to change you the evenness of this expression. It stay always even, because even multiplied by odd is giving you even. Okay, as you see here. So why I'm taking m is superior to the 1? Because we are looking for the positive solutions. We already done with the negative solution before, okay? So now, what I'm trying to do, I'm going to solve my equation by replacing this expression into the original equation, okay? So m equal to 2 to the x minus 1, okay? I'm going to insert this y into the original equation. So we have 1 plus 2 to the x plus 2 to the x plus 1 equal to m 2 to the x minus 1 quantity square, okay? I'm going to solve this one. This one is giving me m square. This one, square of this one, which is 2 to the x minus 2 times, which is m 2 is giving you this one plus 1, okay? I'm going to cancel out number 1 from both sides. I'm going to divide the whole thing by 2 to the x, okay? Is giving me 2 to the x divided by 2 to the x is 1. So this one is giving me 2 to the x plus 1 over 2 to the x, which is 2 to the x plus 1. So this one m squared, if I'm dividing 2 to the x by this one, is giving me m squared 2 x minus 2, okay? This one divided by 2 to the x equal minus m, okay? What I'm trying to do now, I'm bringing m to the other side and 2 to the x plus 1 to the right side, okay? By rearranging these terms. So 1 plus m equal to 2 to the x minus 2 m squared plus a minus 2 to the x plus 1, okay? So this one, I'm going to factor 2 to the x minus 1 minus 2. So it's giving me m squared minus 3 minus 2 to the 3, okay, which is 8. So now, since we know x is superior than 3, this equivalent x minus 2 superior than 1, okay? That's mean 2 to the x minus 2 superior than 2, okay? That's mean m plus 1 equal to 2 to the x minus 2 factor m to square minus 8 superior or equal to 2 times m square minus 8, okay? So this one equivalent m plus 1 superior to the m square minus 8. I'm going to rearrange these terms. This is inferior or equal to 0, okay? By rearranging these terms. So now I'm going to solve for m. So if you take a look, we are going to give the general picture of this function. This is upper face parabola, this one, because minus 17 is coming on the bottom, so minus 17 will become here. So this is general picture of this one. Okay, so this function should be negative. What does this mean? Our solution of this inequality in this region, okay? Because this one, it represents the large root of this one, because it has an intersection with horizontal axis. So that's mean we choose m. We already choose m superior than 1, okay? Okay, so that's mean 1 is superior than, I'm going to solve this one. This was a form quadratic equation. I'm going to solve it easily. So let's take we are taking the positive solution because we don't care about the negative, because m is superior than, m is superior or equal to 1. I'm going to the positive solution. I'm going to apply the quadratic formula here, which is minus b, which is 1, plus square root of b square which is 1 plus minus 4ac. Minus 4ac, that means minus 4 multiplied by 2 and minus 17 is giving you 136 over 2 to a. That's mean 4. If you evaluate this one quickly, if you evaluate this one quickly, you will have this one less than 4. Okay? M is a odd or real proof. That's mean M you will be taking 1, 3 because it's odd. Okay? It's not gonna take 4 because it's less than 4. Okay? I'm going to check my equation. This is my equation for M. Okay? So I'm replacing number 1 here. So 1 plus 1 equal to 2 to the x minus 2. 1 square minus 8. This is not a solution of this equation because we have this side is negative. 1 square minus 8 is a negative. So this is impossible. This is not a solution of this one. So 3 is a solution of this one. Let's replace 3 in order to find x. Okay? Let's insert 3 into this equation. So 3 plus 1 equal 2 to the x minus 2. M squared is 9 minus 8 is 1. So this one is equal to the x minus 2. As you see here, this is 3 plus 1 is 4. I can rewrite on this form 2 to the 2. I'm taking just this one equal to 2. So that's mean x minus 2 equal 2. This one is mean x equal to 4. Now I'm going to replace 4 into this original equation to see what's the y. Okay? So now 1 plus 2 to the 4th plus 2 the 4th multiplied by 2 to 8 plus 1 is 9 equal to y squared. This is the arithmetic job. If you do the arithmetic calculation here, you will find y squared equal 529. You will find y plus minus 23. Okay? So the solution of this one now, the solution we have for the x, we have 4 minus 23 and 4 23. Okay? This is new solution for this one. Let's move on to find another solutions. Okay? Now let's consider y minus 1 is a multiple to the x minus 1. This is the second case. Because we have choice. Okay? Because before we have choice. Now we will prove this one, then we decide which one is a multiple of this one. Okay? Now we have y. Let's solve for y. Now I'm going to rearrange these numbers. Y. Let's solve for m. Let's solve this equation by rearranging these terms by taking number 1 to the other side equal to m 2 to the x minus 1 plus 1. I'm going to do the same thing as I did before. I'm going to insert this y into this original equation. So I will have 1 plus 2 to the x plus 2 to the x plus 1 equal to m to the x minus 1 plus 1. Okay? Square. So that's mean 1 plus, I'm going to solve this one. So 1 plus 2 is giving me m squared 2 to the x minus 2. Okay? By taking the square of this one plus 2 times m, which is m, 2 multiplied by 2 to x minus 1, which is x minus 1 plus 1, which is 2 to the x, plus number 1 at the end. Okay, I'm going to cancel out number 1 from both sides. What I'm going to do now, I'm going to divide the whole thing by 2 to the x. I will have 1 plus 2 to the x plus 1, okay, equal to this term m squared. Dividing 2 to the x by this one is giving me 2 to the x minus 2, okay. 2 to the x divided by 2 to the x is this one divided by 2 to the x is giving me m. Okay, I'm going to rearrange these terms. This one 0 is a superior than this one. Okay, what does mean? This is implies m squared minus 8 is inferior than 0. I have two choices here. M it is taking m to equal 1, or m. So now the m equal to 1 and m equal to 2. You have two choices. I'm going to insert these solutions into this my original expression to see if this equation has solution or not. Okay, this is the original equation. Okay, so 1 minus 1 equal to 0, equal to the x minus 2, m squared 1 minus 8, so 1 minus 8 minus 7, so this is 0, so this 0 equal to 2 to the x minus 2 to the minus 7. This is impossible, so m equal to 1 is not solution. 2 to the x minus 2, 2 to the 2 is 4, minus 8 is minus 4, minus 4, minus 4 equal to minus 1. This is impossible as well, so I have no solution for this one now. I'm going to summarize this. Summarize this one now. Let's move on to summarize this one. Let's move on to the last step. Let's move on to summarize this one now. Let's clean up the board and move on to summarize this one. Now the solutions. Now we have the first one, 0 minus 2 and 0 2. We have 0 minus 23 and 0 23. Now I have only 4 solutions. Now I have only 4 solutions of this equation. I have 0 minus 2, 0 2, and 0 minus 23, and 0 23. Now I have done with this problem. This is a good place where I can stop. Thank you for watching. I will see you in next video. Bye.